Charles' law states that at a constant pressure, the volume of a fixed mass of a gas is directly proportional to its absolute temperature. Okay, so that means that if the volume of a container is increased, the temperature increases. If the volume of a container is decreased, the temperature decreases. Okay, so how this happens is that as the temperature increase, okay, the molecules will move faster, okay, and they will collide harder with each other. Okay, so when they collide, they will push each other further apart. Okay, so this will cause the volume to increase. So same goes when we decrease the temperature. Okay, so when we decrease the temperature, okay, so the molecule will slow down, okay, and they will come closer to each other. Okay, so the volume will decrease. So mathematically we can represent it as V over T equal to K. Okay, so K is the constant, V is the volume, and T is the temperature. Okay, when we have a condition when we have to compare between two situations, the before and after, okay, we can write the Charles law as V over T1 equal to V2 over T2. Okay, so remember that the temperature must be in Kelvin. Okay, so graphically we can say that when we plot V versus T, okay, in Kelvin, okay, we're going to get a straight line. When we draw V over T versus T, or V over T versus P, we're going to get straight line parallel to the x-axis. Okay, so remember that Charles law is V1 over T1 equal to V2 over T2. Okay, it is a relationship, okay, direct relationship between volume and temperature. Okay, so as the temperature increases, okay, the gas will expand. Okay, means that the volume will increase. Okay, as the temperature decrease, the gas will contract, means that the volume will decrease. Okay, so here are some example of the real life application of Charles law. Okay, so hot air balloons is one of the classic example of Charles law. Okay, so let's see, okay, how the hot air balloons apply Charles law. Okay, so when we turn on the burner, okay, to heat the air balloon, okay, the gas particle will move faster and push each other apart. Okay, so this will stretch up the balloon's canopy. Okay, so as the volume occupied by the hot air increases, okay, its density will decrease. Okay, so this will allow the balloon to flow, okay, to flow in the cooler, denser air that surround it. Okay, so another example we have bread. Okay, so bread dough rises because of the yeast produce carbon dioxide. Okay, so when we place it in the oven, okay, the heat will cause the gas to expand and the bread will rise even further. Okay, so same goes if we have an example of a dented ping pong ball. Okay, so how we're going to fix the dented is that we put it for a while, or we dip it for a while in a warm water. Okay, the temperature of the air inside the ball will increase, therefore the air will expand. Okay, so the ball is inflated and then are fixed. Now let's see the calculation with the Charles law. A helium balloon in a closed car occupies a volume of 2.32 liter at 40 degrees C. If the car is parked on a hot day and the temperature inside rises to 75 degrees C, what is the new volume of the balloon, assuming the pressure remains constant? Okay, so first of all, okay, take out the information given in the question. Okay, so we have here the volume and temperature before, and we have temperature after. Okay, so remember that we have to convert the temperature degree C to Kelvin. Okay, so always remember that the temperature must be in Kelvin. Okay, so we know that the Charles law is V1 over T1 equal to V2 over T2. Okay, so we just plug in the info given in the formula. Okay, so we cancel out the unit for Kelvin. Okay, so therefore we're going to get the volume is 2.58 liter.